Hey everybody. As you can see, I got a neat little contraption here that I actually fabricated for my math students. I do math lessons this way. And so I'm going to use this just to go over what we just learned in the note with you as well. So first of all, we talked about the subatomic particles. Subatomic means the parts of an atom. So subatomic, sub means parts of, and this means an atom. So parts of the atom. And we have three parts of an atom. We have the protons, we have that's a plus, our neutrons, and we have our electrons. And for weight, we know that protons weigh 1 unit, neutrons weigh 1 unit, and electrons, we're going to say they have no weight at all. No weight at all. So for carbon 12, or so for carbon, and I'll do a couple cat things here. So the atomic number and the atomic mass or weight. So carbon has a mass of 12.01 and atomic number of 12. The atomic number tells me that carbon has 12 protons. Sorry, I've messed up here. Atomic number carbon is 6. So carbon has 6 protons. I know rounded, its weight is 12, so it must have 6 neutrons as well. So a weight of 6 and a weight of 6 gives me a total weight of 12. And because carbon is neutral, it has to have the same number of electrons as protons. So we get 6 of those as well. If I look at sodium, and you can refer to your periodic table where I'm getting these numbers, sodium has an atomic number of 11, and it has a weight of 22.99, which we are going to round to 23. That also tells me that because the atomic number is 11, sodium has 11 protons in its nucleus. Because sodium is neutral, it would have 11 electrons as well. And to get a weight of 23, we have a weight of 11 with the protons. That must mean that we have 12 neutrons to get up to 23. And I'll do one more with you. Let's do chlorine. Chlorine has atomic number of 17 and a weight of 35.45, which we're going to round to 35. I guess rounded down. The atomic number 17, that tells me that we have 17 protons. Because all atoms are neutral, I would have to have 17 electrons as well. The pluses and the minuses balance each other out. And I would have to have 18 neutrons, because 17 plus 18 gives me a weight of 35. So we talked a little bit about isotopes as well. So for carbon, a common isotope is carbon 12, carbon 13, and carbon 14. These are the 3 isotopes of carbon. And isotopes just means that they have a different weight. So we know that carbon has 6 protons. That's what makes it carbon. 6 protons. We know that because carbon is neutral, that it's going to have 6 electrons each time. And carbon 12, that's the weight, the mass, it would have 6 neutrons, because 6 plus 6 is 12. Carbon 13 would have 7 neutrons. Carbon 14 has 8 neutrons. So these are all carbon, and this is what makes it carbon, the number of protons in its nucleus. But some carbon atoms have an extra 1 or 2 neutrons, which just give it extra weight. Now we're talking about Bohr-Rutherford diagrams, so you're gonna have to draw some of these up. So if we're to draw up carbon-12, carbon-12 has atomic number 6, so 6 protons. It has a weight of 12 rounded, so 6 neutrons and 6 electrons. So the way I draw this is I draw my nucleus, and I say that it has 6 protons and 6 neutrons in the nucleus. And we also have 6 electrons. And remember, electrons, the first orbit will hold 2, the second and third orbits will hold 8, and the fourth one will hold 18. So I'm going to draw in my first orbit. A good way of drawing these is to think of north, south, east, or west, or a clock, 12, 3, 6, and 9 in position, and to draw your electrons there. So I'm going to put 2 electrons in my first orbit, and for the first orbit, it's a good idea to draw those in the 12 and 6 position, or the north and south position. I still have 4 more electrons, so I'm going to draw a second orbit, and I'm going to draw 1, 2, 3, 4 more. Once again, you see the 12, 3, 6, and 9 position. There we go, that's drawn up. If we do fluorine 19, so that's the isotope that has a weight of 19. So fluorine has atomic number of 9. So it's got 9 protons, 9 electrons, and because it weighs 19, it's going to have 10 neutrons. So drawing that up, my nucleus, 9 protons, 10 neutrons, and I have 9 electrons. 1, 2 in my first orbit, it's full. 3, 4, 5, 6, 7, 8, 9. So there's my 9 electrons, 2 in the first row, first orbit, 10 in the second. So that is that. Hopefully this will help you out.